Jeez. Yeah.
All right.
No. Anyway. Such is life.
You ready to go?
Yeah, I'm ready to go.
I'll hit broadcast then.
Yeah, no problem.
We're off.
Yeah.
Attendees, hello everybody.
Oh.
96, 99. Hello, hands up waving. Liberato. Rosa. Aaron. Well, everyone's put their hand up. Okay. Hello, everyone. Hey. Good morning. Good morning. Okay. Quick go through the names. Hey, Stuart, Richard, Tom, Paul, Sam, Gary, Daniel. God, I just yeah. Okay.
And us.
And everyone else. Mike, Gary, Aaron, James, Nigel, Chris, Spencer, Mark, Ben. Morning, mate. Okay. Good morning. Welcome to day 2 of webinars. Long day yesterday. I was even doing a podcast last night with the E5 lads and Dane, and actually we discussed something which we'll bring up in today's webinar. This morning we're going to discuss. Well, I put it up as EICR's the missing test, but we've kind of just gone into the inspection and testing subject overall. So we're going to talk about initial verification as well. Phil's back here with us, and he's going to run us through a presentation. And we're basically just going to have a chinwag, really. It's more of a, not so much a presentation, it's more of a points for discussion. And so everybody else in the chat, let us know your opinions, and if you think, what your opinions are of testing and how it is now, and, if there's anything that you
how it could
we
be.
need to think about for this. Okay. I've got my BS7671 in front of me. I've got guidance notes 3 over here. Is there anything else I need, or we're going for it?
No, let's crack on. If everybody's ready. Yeah. As you say, this is just a general discussion. We've got a number of PowerPoints, not so many, but we're just going to highlight various issues. And these, again, are my opinion. And, yeah, shoot me down in flames if you want.
It's worth, yeah. It's worth, hey, Robin M., it's worth mentioning that you and I have been delivering the 2391 for
a number of years.
Years. The old one, the 2394, the 2395, the current one, and the design. So we have been involved in the delivery of, and so we have a bit of an understanding about what the classroom experience and, in particular, the City and Guilds experience is like. Yeah. Okay. And plus, we also do it in the field.
Yeah, we do it in the field. And we do tend to train the same way. We both sort of teach people the same way of testing, including some of the tests that we're going to talk about this morning, which are not in the actual sequence of tests as shown in the on-site guide or guidance note 3. So I think we both sing from pretty much the same hymn book.
Pretty much.
You occasionally give me the odd slap, but apart from that, we sing from the same hymn book.
I occasionally face palm and look the other way.
But that's natural, Yeah. Remember, I'm getting old. Anyway, okay, guys. Looking at some of what we consider to be the missing tests, inspection and testing. So, we're going to also look at some of the records, the missing records, because we do a number of tests that we don't actually record. We just put silly things on the form, or don't even put anything on the form at all. We're going to follow the recommended sequence from the guidance note 3. So any numbers you see on the PowerPoints refer to guidance note 3, not to the regs, not to the on-site guide. They're from guidance note 3. So if you haven't got a copy of guidance note 3 in front of you, it's not important. It's just, if you have got a copy, you can then sort of follow it through that as well. Okay, let's have a look at the first one we talk about when we're looking at guidance note 3, 264, continuity of protective conductors, and this includes main and supplementary bonding. Okay, and that's normally the starting point for all lines inspection and testing sequence. We want to make sure that the earthing and the bonding is adequate. If the earthing and bonding is not adequate for the system we're putting in, then we might as well not bother. Because obviously when we're talking about protection against electric shock and stuff like that, it all relies on having a proper earthing system and a proper bonding system. So if we haven't got that right, then it's like building a house without foundations. It's going to fall over.
But we do that one, don't we?
We do this test. We do this test, and we generally use method 2 to check our bonding. And what it says is we're looking for a result of somewhere around about 0.05. This is the number that's generally thrown around
The magic
when
number.
we're checking our bonding. And then what result do we put in the EIC or the ICR? Yes, we put a tick. So fantastic. We've done a test. We've got a test reading. But instead of actually putting that reading in onto our document, we stick a tick in there. So
it's worth me adding right now. I have seen some lads take it upon themselves now to actually start writing a value. I think companies like Electroform allow this functionality, I believe, or someone else. And anyone who's doing that and taking it upon themselves to do a bit better than the form, fantastic.
Well done. Well done. Yeah. If you consider, it's like going to the bank, isn't it? You go to the cash point or something at the bank and you want to take some money out. You take the money out and you say, okay, what have I got left? And instead of saying an amount, they give you a tick or a thumbs up. So yeah, you've got money left. Yeah, fantastic.
Yeah.
And you go a week later and you've had some more money go out, more money go in, and you want to get a balance and you go to the cash point. You say, right, what have I got? And they say, yeah, you've got money. It's pointless.
I think
you can't see.
I think from my memory, it's you don't have to test it if you can verify its presence along its entire length visually.
Yeah.
If it disappears and reappears
entirely throughout its length.
Yeah, if it disappears and reappears, you've got to check it, and this is the magic number that we need to aim for. But I think if I remember calculating it, it's about 25 meters of 10 mil. If the resistivity value, if you were to look at the resistivity value of 10 mil, if you had 0.05 for something that's the other side of a wall, which is 2-3 meters away,
you wouldn't be very happy with that.
That can't compute. So we need to actually, understand what 0.05 is of a conductor.
Yeah, and this is what we're saying, is it totally disregards the length or the size of the conductor. If we take a bog standard figure of 0.05, if you've got 1 meter of cable, which goes through a wall and then goes onto a pipe the other side, and you get a 0.05 reading for that, that basically is a crap reading. Compared to maybe 20 meters of 10 mil, giving you the same reading. It can't be right, can it? You can't have the same reading for 20 meters of cable as you've got for 1 meter of cable. So my argument is, let's measure it and let's put the proper number in there. Now we can calculate these values from the tables in the back of the on-site guide and also in the back of guidance note 3, table B1. So why aren't we calculating the values and then measuring it and then comparing the measurements against what we calculate, doing the job properly, rather than this, if it's 0.05 or less, we'll give it a tick and move on. It seems to me inconsistent with, doing the job properly and safety.
Yeah.
Also, if you're going back to do an EICR at some point in the future, you've got something to compare it with. How do you know whether or not it's degraded? How do you know whether it's, the connection is going downhill? You say about the fact that, we do it with cables that might disappear into the floor or into the wall. We don't know if there's connections in there. And over a period of time, those connections could start to break down. If we take a reading and we actually log it on the actual record, then we can compare that when we go back to doing EICR. Hang on, this is going downhill. The result is increasing. What's going on? We might have started off at 0.01. We're now at 0.04. Well, actually, that's a degradation. That's showing that the thing is not as good as it was. So it's important information. So why aren't we recording it? And that's the basis of our argument on that first one. So we then go on to continuity of protected conductors for final circuits, and that's commonly carried out using the old method 1, R1, R2. Yeah. And there's a number of ways of doing this. I prefer, personally, to have my cables hanging out of the board, and I do my connections on the end of the cables, and then I go around the circuit. I see some training material which shows a link between the MCB and the earth bar with the cables all terminated into the earth bar.
I think one of the problems is it's illustrated in a number of different ways according to the point of installation, really, isn't it? And that affects how people interpret it or illustrate it.
Yeah, but you do talk to people and they say, oh yeah, I put a link in because that's what it shows in the book.
Yeah.
Now consider if you've got an installation which is conduit and trunking, and you've got a situation where maybe you've got an earth or multiple earths connection to the trunking and the conduit, you may be getting false readings by having your cables connected into the earth bar back at the board, because you've got parallel paths. So by removing those cables, in fact, I do the test before I actually terminate. So by doing it in that way, I'm making sure that I'm actually testing the circuit that I'm trying to test, rather than relying on multiple earth paths with multiple connections to trunking and conduit systems. So that's why I do it with the cables hanging out. You still there?
I'm typing, and you know my keyboard is very loud.
I thought you'd gone quiet. I'm not used to you being quiet.
I've got a clicky keyboard, so I'm muting myself while I type.
Yeah, I'm not used to you being quiet. Okay, so it's the way of doing it. First of all, yeah, I recommend whenever I'm teaching guys, training guys, always have the cables hanging out. In fact, what I tend to do if I'm doing an install is I will do the continuity tests before I terminate the cables. Yeah, and the idea is that why do you want to keep this? When you come to ring final circuits, why would you want the cables into the MCBs and the earth bar and the neutral bar, and then when you come to do a continuity test, oh, we've got to take them all out again. You're now chewing up the MCBs and the end of the cables. It's pointless. So I have to normally have the cables hanging out, and then I'll do the continuity tests before I terminate them in at the board.
Mm-hmm.
Now, obviously, once we've done our continuity of CPCs and we've gone around and done our normal thing of, we check the polarity at the same time, we can check at every point, we can check the operation of functional switches on lighting, we can check all that stuff. Great, no problem at all with that. But what we then fail to do quite often is to actually do the calculation to compare the results we're getting, with the length and size of the cables. So again, in the back of guidance note 3, we've got the tables there which will give us values. So what I prefer is to have a calculation first, and I always teach guys, do your calculations first. Once you've done your calculations, then do your tests, compare the results you've got with the test values in your calculations, and if they're in the same sort of area, fantastic. If they're not, you've got a loose connection. And it's amazing how many times we can actually identify loose connections in circuits, by doing the calculation, then doing the test, compare the two.
I agree. I mean, when I deliver the training, and I'll have some guys in some rigs or on a site, before we actually set up to do the test, we've got everything configured. Before we press that button, I go, what do you think it's going to be? We know the size, we know the approximate length of a conductor. And then we'll come up with a number, and I go, oh, okay. And then we'll journey down maybe twice as far. I go, what do you think now? And I go, doubled. And you get them thinking about that. And then we'll go on a switch drop, and we look at the increased resistances. Then we understand actually, well, the switch line has come back. And, we get them thinking about the value before they press the button. It's very important to think about the values you're going to receive, because the test instrument is just a tool. You've got to actually understand the values that you obtain. We don't just press it and take the number and put it in the form. We've got to compute. And that's, again, especially with initial verification, because this is the way we're going to identify. This is the way we're going to identify if that brand new light switch or that brand new socket outlet has contact resistances. Same as, I'm probably jumping ahead, but same as if we're going to do the R1, R2s through the front of the sockets, we should do both in case one of them is defective and is increasing that earth loop impedance, always think about the numbers before you actually obtain them. I
mean, I'm actually, as you know, I'm actually designing a new set of test documents, and I'm actually putting within the test documents a box for calculated values. So when the calculated values are done, and then when you actually go to do the test, you put your test values in and you can compare the two. All right, so it's a good tool for comparison. And it is amazing how many times, and I've done this with apprentices and guys in the training field, and amazing how many times we come across loose connections and we've identified it by doing that calculation. Go around, tighten up a few screws. Fantastic, it's much better now. Okay, so that's something to consider. We need to know, rather than just pressing a button and taking a number, we can teach monkeys to do that. It's take the result, compare it with the calculated values. You know the size of the cables, you know the length of the cables. Okay, do that calculation, compare your values. I've also mentioned there about parallel pass-through metal containment. Again, parallel pass-through supplementary and main bonding. Again, if you're doing your test with your cables connected, you're going to get all these things affecting your test results. So again.
So if I had a cable that ran, let's say I ran a CPC through a steel conduit,
Yeah.
Especially with a new installation, is it best for me to try to test prior to connecting it to the parallel to identify the parallel? Or should I connect it and then just compensate that the parallels will give me, basically, I won't be able to determine that protective conductor's continuity if the parallel is there.
This is it. When you do your calculation, if you're using metal conduit, metal containment, when you do your calculation, you will find that when you do your test, that, hang on, these readings are actually lower. Yeah. And that's because of your parallel paths. Now, okay, we can't sort of go around and sort of undo every single connection or wait to do every connection. But the one at the board, I think, is the important one. Don't connect it in at the board, okay? To remove some of those parallel paths, test the cables before you terminate.
I think also what's quite important is to make sure, I mean, if your parallels are part of your wiring system, then all of that is stationary. It's if you have parallel paths that are through alternative means, that could be temporary. You know, that's what we don't want to actually record and actually, you know, accept.
So, another thing you can highlight is if you've got metal containment, metal trunking, you do an R1, R2 test, and you get a reading which is much, much lower than you expected from your calculation. That could be highlighting that you've actually got a live conductor caught maybe in the turnbuckle of your trunking.
Yeah.
You know, halfway down the actual circuit, you've got this fault, and you're getting a much lower reading because you've got a much shorter path.
But it's so easy just to go, oh, well, that's parallel.
Yeah.
You just automatically tick, oh, yeah, that's parallel, and then you carry on. And again, that's an important reason as to why the installation resistance test follows this test.
Absolutely. When you do your installation resistance, hang on, I've got a dead short.
Yeah.
Okay. And then one of the problems we have is that guys will then go and find where the fault is, repair the fault, and then won't bother doing the continuity test again. Okay. So if you've got a fault like that in a trunking system, where you've got a dead short between your line and your CPC, then remember, once you've repaired that fault, you've got to go back and do your continuity test again, because it was that fault that was giving you continuity in the first place. Yeah. So we've always got to consider, whenever we find issues in the testing inspection process, right, how that has affected previous tests. Yeah, and we have to go back and repeat those tests to make sure that they are now giving us a proper reading. So yeah, okay, we do the R1, R2, and I've got, you know, no issues with the actual practical way of doing it. It's just the calculation and some of the business of not connecting at the board. The problem then, all right, we go on to ring final circuits. Okay, but what have we forgotten? Well, think about your radial circuits, your lighting circuits. Nobody's tested the neutral.
I haven't got a box for neutral.
No, isn't the box. This is one of the big issues.
Why should I?
Standard documentation doesn't provide you with a box. And what I've been teaching for years with guys is that on your schedule to test results, you've got two columns. One is for R1, R2. One is for R2 alone, which I generally use when I'm doing EICRs and I can't turn the circuit off. I can go around with a wandering lead and still prove I've got an earth. So I generally only use that for EICRs. But if I'm doing an EIC, all right, I've done my R1, R2. That's a better test to do anyway, because I can prove polarity and functional switching and everything else during the process of that test. The R2 column then stays empty. So what I tend to do is I will change that to R1RN. Yeah, and I will then do the same process. I will connect the line and neutral together at the fuse board, and I will go down the circuit and I will test that I've got continuity on the line and neutral. That effectively gives me an R1RN value, and I record that on the test sheet. We don't test neutrals. Why in hell don't we test neutrals? And at countless times, I've been to installations that have been wired by other people, and you get there and they're saying, well, half the lights don't work. And you know before you even start that it's going to be a problem with a break in the neutral. Yeah.
There's some interesting comments coming up in the chat. Did you want me to collect them for the end or kind of bring them in as we go through?
Throw them in as you go, if you like. We'll just see how the time goes, yeah?
Yeah, okay. You carry on the sentence and I'll find some. Right now.
I mean, I remember one particular circuit in a major sporting complex where we actually had one circuit of lighting we were brought in to look at because it had loads of faults in it, wasn't working. and it had 4 breaks in the neutral. As you went down the circuit, okay, there was 4 occasions where the neutral was broken on one circuit. It's just ridiculous. Okay, so testing of neutrals will overcome that. We'll make sure we've got neutral all the way down the circuit. It's, for a start, it's less embarrassing when you turn everything off at the end. Turn everything on, and half the stuff doesn't work, and the client looks at you as if you're a complete wally. But secondly, and more importantly, if you're not testing the continuity of your neutrals, when you come to do insulation resistance testing, you are not testing part of the circuit. You're not including those conductors. So another thing that happens is that turn everything on, half the lights aren't working, for instance, you repair the joint in the neutral or the connection in the neutral, turn the circuit back on, not thinking, and then there's a big bang because you've actually got a dead short further down the circuit which you didn't pick up because the neutral wasn't connected in the first place. Okay, so it's it's one of these things. Why don't we test neutrals? It's always astounded me. It's a current carrying conductor. Why aren't we testing the thing? Okay, so I tend to do this after I've done my continuity of CPC. I've done my R1, R2. I would do it, and I would do an R1, RN. And I, as you know, and you do the same. We teach apprentices and we teach everybody that we have on the training courses for testing inspection. We teach them that approach. All right. It's got to be the way forward.
It gives us data that we need. Okay, so a comment going back to when you mentioned about doing your continuity prior to connecting, so with them loose. There's a couple of points to say. So how are you going to verify the integrity of the connections if your continuity tests are carried out prior to connection? So
the circuit is all connected. Yeah, the
circuit's connected. So you're just talking about at the DB.
I'm only talking about the final connection at the DB.
Right.
I have my cables all coming back to the DB, and I don't terminate them in at the DB. I will have them hanging loose. I'll do my continuity tests. Once I've done my continuity tests, I will then terminate the cables. Because when it comes to insulation resistance testing, I do want them all in at the DB because you've got all those parallel paths then. Yeah.
And so you'll verify that last connection when you do that one, and then all the other connections are checked with your. All
the other connections are done. The circuit is complete. Apart, of course, if I've got PIRs and photocells and stuff like that, which are going to affect my insulation resistance testing. Yeah. So anything that I've got disconnected for that, I'll leave out. And I always say to guys, you've got to install in preparation to test.
Yeah.
What is the point of installing everything, connecting everything? Then you come to do an insulation resistance test. I've got to go and disconnect everything now.
This does become a big problem though when we have one team installing and one team commissioning. It does become an issue. I'm not a fan of that either.
I'm not a fan of that. Never have been. I just think if you're an electrician, you should be able to install. You should be able to test. It's like if you're gonna jump out of a plane with a parachute. If you know about jumping out of planes, you'd rather check your own parachute rather than leave it to somebody else. Why get other people to test your work? You want to test your own work so that you can make sure it's all functioning, all working before you leave. It doesn't make sense to me having different people testing.
Nick's got an interesting point here. So he says, I thought testing without parallels was giving you a worst case scenario. With parallels in place, your impedances will be lower.
Yes.
So but testing without parallels. What's the problem with having them in?
You're getting lower readings. The other thing is,
problem with that?
You're getting lower readings, but also you're having false readings because if you've got a connection to your earthing buzz bar or earthing bar in the back at the board, you may have a number of circuits. Say you've got talking about a metal containment system, conduit trunking, and you're feeding 6 lighting circuits down there, right? All of those lighting circuits will have a connection via the CPC to the conduit or the trunking system.
Yeah.
Okay. So if you're testing circuit 1, right, and you've got it connected into the earth bar, even if you've got a break in that, you'll get a reading off of it because every other circuit is also connected to the same trunk into the same conduit.
Yeah, and that's, fundamentally, this test is called continuity of protective conductor for that circuit, and that's the point. We need to verify the integrity of that one conductor for this. But there is a point to actually cover here, though, that we do need to we'll cover the ZSs a bit later, with the parallels in place, because those reduced impedances do have a negative consequence, don't they? Which we'll cover in a bit.
Yeah, parallel paths, absolutely fine with that, because obviously it's reducing the overall impedance. But all I want to make sure of is that each individual circuit has actually got a proper earth.
Yeah, that's required to be a
proper
7671.
CPC. Yeah,
Yeah.
And it's not relying on the other circuits and the multiple sort of connections to the trunking and the conduit, and they're providing a they're covering the fact that you've actually got a break in this circuit. You're still getting the reading, but there's a break in the circuit further on down. And this is one of the issues. It's difficult with metal containment, but one thing, as I say, leave the cables out at the end and test from the board, and then terminate before you go on to insulation resistance.
Okay. A couple of people saying, I was taught to test the neutrals on my 2391, which is great.
Great. Fantastic.
The R1RN test only takes 5 minutes to carry at the end of the circuit. Never understood why you wouldn't do that.
Absolutely.
Do the NIC certs not cover the neutral R1 plus RN test to record it? I'm not sure. They may have.
I don't use them.
All we know is the model form in BS7671 that I got in front of me does not.
No.
It does not have an R1 plus RN column.
The model form doesn't. The on-site guide doesn't have it in the sequence of testing. The guidance note 3 doesn't have it in the sequence of testing.
But many organizations, such as Electroform as well, are kind of evolving their certification.
Fantastic. And that's great. And that's what we want. We want it to, but why isn't it recognized by the IET?
I don't know.
People look to them for guidance. This is one of the big issues in the electrical industry, is the fact that we don't get a standard of guidance from all points. We've got all these different ideas, and everybody looks to the IET for guidance and to lead the bloody thing, but they're falling behind. It's a bit of a shame, really.
There's two interesting comments here. Kenny says, Mr. Nick Hanley of the NICIC taught us to do this on the 239152. So the NIC teach you to do R1 RNs, but then Stuart says, but the NICIC forms don't have the space for recording it.
Yeah. Okay. So that's a bit of an issue, isn't it? Yeah.
But I should imagine it's I think a lot of people are starting to see the benefit of doing it, and I think a lot of people are starting to evolve beyond that. And I've had a chat with Mark Colson, similar at the committees, and we kind of moan about the lack of improvement here. I mean, we've added the AFDD, and we've taken away the other functionality for RCDs, which is just even more frustrating. It just needs to be redone a little bit here.
Yeah, and this is why, personally, I don't actually use anybody else's documentation. I actually design my own and use my own.
No, it's
fit for purpose.
As I say, and we say with the E5 guys when we do that, work from the regs, which means if your work falls down, it lands on the regs.
Yeah,
it's a foundation, but add to it, enhance from it.
Yeah, the IET forms are the basic minimum, and they're the absolute minimum. And I have that plus many other things. And people have got to not be worried about it. We mustn't be scared about improving and going our own way and having our own forms. There's a lot of really good electricians out there. There's a lot of guys that really, really know what they're doing, and the basic forms are letting them down. So if you want to design your own forms and have them laid out how you want them, crack on, guys. Believe in your own ability. You know what you're doing, and nobody can have a go at you about it as long as you've got the basic requirements. Plus, it's the way forward.
Cool.
So testing neutrals. The other thing about this, of course, is that it proves our continuity of our neutral. It gives us comparison with calculated values. So again, we can see if there's any loose connections. If you consider a loose neutral, why are we so worried about loose connections in the live conductor and not worried about loose connections in the neutral? It's a current carrying conductor. If there's current loading on the circuit, it's going to arc, it's going to overheat, it's going to catch fire. It doesn't matter whether it's the line or the neutral conductor.
We know it was one of the main culprits for the reason why we now have metal boards, because of that neutral terminal not being given the same due respect, because it's not getting the maintenance.
It is total nonsense. Also, obviously, it stands to reason we need to test the neutral when we're proving polarity on radial socket outlets, and most people will do that anyway. The other thing about the R1RN value, it actually gives us a useful value that we can use when calculating volt drop.
It technically gives us a measurement of circuit resistance, isn't it?
Yeah. So we can almost simply multiply that by the design current for the circuit. Hey, there's your volt drop.
Times 1.2, I think, wasn't it? Which was that?
Make sure you multiply by the 1.2 for the increase in temperature when the circuit is being used. Yeah. So as long as you follow the calculations using the proper factors and everything else, it gives you a proper reading for calculating volt drop.
Nice.
What, as
So,
I say, in my test sheets, I don't, even if you're using the standard test sheets, you can use that R2 column if you need to. Just change it to R1 plus RN. That's what I do with the standard test sheets when we're doing training. So if you're using standard test sheets or any other test sheet where you've got an R1, R2 plus an R2 column, well, you could just adapt that to R1, RN if you're finding problems.
it does seem a waste to have an R1, R2, or R2 column. It just why can't we just have an R1, RN, R2 and scratch out or do that and then have an R1, RN column? If real estate is the problem here with this model form, if that is, because I've heard that excuse a few times, real estate, there's not enough space, and it needs to just be a bit more sensible. With
have another form. Well, expand the form. That's what I've got. I've got 2 pages for it.
Yeah.
And the new one that I've designed, I've got 2 pages for the test results and all the circuit information. I just don't think there's enough room on that form. We're forever trying to squeeze in numbers onto those silly little boxes, and in the end, I mean, especially with my eyesight, now I'm getting old and crotchety, it's a real struggle to read it. So why not split the form into 2 sides? Maybe we can have live testing, dead testing, and make the boxes bigger and provide more boxes so that we've got the right number of boxes for the sorts of tests that we're going to be doing. So we can record everything, all those important values. Okay, so then we go on to continuity of rings. And again, we've got the same issue. We do the continuity of ring, we do the end-to-ends, we do the crossover of the line and neutral, we get an R1, RN value. And then we go on to step 3, we do the crossover of the line CPC, we get an R1, R2 value, but we only record the R1, R2. Why don't we record the R1, RN? We've taken a value. This is even more ridiculous. We've taken a value, we don't even record it.
This is another thing that I see. I see a lot of people skipping it because they don't have to record it.
This is an issue.
Yeah, a lot of people evolve their work because they only do the work necessary to fill in the form. I mean, the very first comment I saw today was about these housing associations, and some of that are pushing for up to 8 or 10 of these jobs a day, and that's what's happening is people will be rushed. I mean, we're going to talk about inspection a lot more tomorrow, but we're sacrificing the actual technical component of this work where the real magic happens to get numbers to put into the fields. And so tests like this R1, RN for ring finals, there's no field for that. It does become overlooked or skipped.
Yeah. It's such an issue at the moment, is this business of, you can bang out 8 tests a day and do it so much per circuit. And we've got to start thinking about these things, and we've got to start digging our heels in the sand and say, no, we can't do this. And if everybody did it, if everybody sang from the same hymn book, then we could actually charge the right amount and spend the right amount of time when we're doing inspection and testing. And I always think about, if you took your car down to the garage for an MOT, would you feel happy if the mechanic just kicked the 4 tyres and said, yeah, that's okay? You wouldn't feel happy about it. So why are people happy about rushing electrical inspection and testing? It seems crazy to me. This is an installation which causes fires, causes electric shock, causes all sorts of other problems. And people are just, let's just rush through it.
There are large organizations that will sell their life to the companies that tell them that they will achieve compliance with their services. And they know that all they have to do is hit this sheet to provide this documentation. And so the people are pushed to do the work very rapidly, very aggressively. The actual skill is lost. And I'm seeing lots of people talking here about putting the numbers on, you could some people were told to put the R1, RNs on the back of the cert because there's no space on the front. People know how it should be done, but the industry, this model form needs to force the hand of those that are actually allowing this rushed practice to occur. If we improve the amount of technical requirement in the model form, then everyone's going to have to come up to a higher level. Because right now we're falling lower than the level that we need to.
Absolutely, yeah. And it is driving standards down. That's the trouble. It's driving standards down. The forms that we've got, the practices that we've got, and this driver of cost all the time and time, is driving standards down. There's no way of getting around it. People are under pressure all the time to produce and to get through a mountain of work in ridiculous amount of time. and we've got to start saying, no, this can't happen. And we've got to start protecting the industry, protecting ourselves, and going back to the customers saying, well, do you want this job done properly or not?
Yeah, and it is a shame. And we've seen, I mean, we were working at a location just recently. We saw large, many stickers from a very large organization.
Oh, God, yeah.
And we're finding observations. We carried out tests, and this installation was 15 years old now?
Yeah, 15, 16
so
years old.
It's had 3 or so EICRs.
It's had three.
And we were doing tests, just a simple loop test, but we were interpreting the information to say that's not going to achieve this. This is unsafe, but it's been in service because people just aren't, putting in the effort or putting in the work.
It's passed 3. It's passed initial verification when it was first installed. It's passed 2 EICRs since then by allegedly reputable companies. We won't go into what badges and whatever they've got. Yeah. And yet we go along, and as you saw, that piece of trunking held up by a piece of rope, swinging in midair. I mean, who on earth would pass that? It's because you took down a hatch and you put your head up in a hole that anyone else would go limb. Yeah, well,
that's why.
But it wasn't even that. I just opened the door up. This was the thing. It was in a cupboard.
It was in a cupboard. It was in one of those limb cupboards.
Well, yeah. Well, you know me. I'm not the most agile of persons. I'm not going to get into all the little nooks and crannies. This was just in a cupboard, and there was a piece of trunking swinging in midair. And you think, how on earth does that pass 3 tests by reputable firms? I come along, not even getting my test equipment out. As you know,
don't need to.
You and me are the same. We spend a lot of time doing inspection because 85% of what you find will be by inspection, not by testing when you're doing an EICR. I don't even get my tester out for the first few hours. I have a good look round. All right, Well, how is it? It's been missed 3 times. And it's all down to cost drivers.
Indeed.
Okay, so again, here we are, ring final circuit. We do an R1RN test. We don't even bother recording it. It's ridiculous. Yeah, and again, we should do the calculations, right? As in the book, do the calculations first. Make sure that we are achieving round about the same values. It doesn't have to be spot on, but close. And as long as we're achieving good values, then we can say, yeah, fine, that's great. But record the R1RN. Don't just ignore it. Insulation resistance. Again, this is a test we carry out, and we carry out tests here that are not recorded. And I think about, again, when I'm talking about insulation resistance tests, the best way of doing an insulation resistance test is to have all the cables connected. So you've got all your neutrals in your buzz bars, or your neutral bars. You've got all your cables terminated in the MCBs, all your CPCs into the earth bar, and you test the installation as much as you can in lumps. We used to be able to test it all as one board. Nowadays, with split load RCDs, we can't do that. We have to test it in 2 chunks.
Yeah.
But we end up doing 3 tests. We end up doing between the live conductors, line and neutral. We end up doing line to CPC. We end up doing neutral to CPC. So we do 3 tests. We've got two columns. Yes, and I know that one is for live to live and one is for live to earth. But we're doing 3 tests. Why not record the 3 values? And what about when we come to 3-phase?
I'm sure I remembered once. I don't know if it was an old NIC form. I'm sure I remember seeing a form that had line to neutral and live to live and live to earth. I'm sure I saw it somewhere.
I'm a firm believer that if you do a test, you should record it. If you've got a value, record it.
Everything you record, yeah.
Yeah. So then you can see any degradation, over time. When you come back to doing EICR, remember EICRs is all about checking a system out, and the testing part of the EICR is to see whether there's been any degradation in the actual system. Yeah.
Just going to
if you haven't got all the test results from the EIC, you're not going to see it.
Just going to bring up one comment here because we just talked about obviously having a site that had three inspections and obviously nothing was found. So Keith has basically said, Phil, are you sure the observations haven't just been missed or were actually missed, but they were just not ignored by the client?
No, it was all. I looked at the documentation. It was all satisfactory. There was nothing on the inspection sheets at all.
But it's worth mentioning that you've had how long a working relationship with this client over history?
Over history, we're talking about best part of 35. 40 years, something like that.
Yeah, and so they've not really asked you to do this kind of work, mainly because you're like a one-man band with a couple of guys helping you out now and then. The scale of the work.
as you know, I shut down the electrical contracting
Started
firm
training.
and I went into training. So
Yeah.
I said cheerio to them and off I went.
So
and then they asked me to come back.
yeah, so you knew the client, and you got the information from the client, and they were under the assumption that all observations were recorded. But I take your point, Keith. I do know that many clients are completely ignorant to actually taking action on any recommendations and just
Oh yeah, yeah,
yeah, that is true.
yeah.
I say
I
this a
always
lot with
go
E5.
back to previous sheets. Always go and look at the previous documentation. I don't. I know, because obviously quite often you'll give a inspection and test sheet to a client and they won't even know what they're looking at. You know.
I say this a lot with E5 guys. The electrical industry, I think of electrical safety first as one of the key people who should push for this. We need to find great ways to help educate clients on the importance of properly sitting down with the electrical inspectors and reading it. Similarly, you know, electrical inspectors need to be able to report things in the correct way with regards to regulation, non-conformance, but also translating it into English for the client to interpret. So there's a bit where we have to find a way for the information to get across. All we've actually done is change the name of the document from a periodic inspection report to an electrical installation condition report. That was supposed to do that, to let the clients understand the document better, but there's not enough work being done for that, I think.
It always amazes me, you talk about information and keeping the client informed. It always amazes me when you come to an EIC, you know, and we're talking about mainly domestic, where we're chasing cables into a wall and then plastering over them, and we have to do it in the zones, you know, and we have to sort of make sure we come down vertically and horizontally, and there's lovely pictures in the on-site guide and building regs book and everything showing where we can run the cables and where we shouldn't be running the cables. And then we don't tell the customer that.
No.
So we as electricians know where the cables should be, but we never give that information to the customer. Now we go away, the customer goes and drills straight through a cable, and we come in fact back thinking, well, what a wally you are, but we didn't give them that information. So I always say to guys now on the inspection and testing courses, give them a copy of that document, show them where the zones are, and inform them not to put, you know, shelves up and mirrors and pictures and whatever in those places. If they don't have that information, they can't act on it.
Wouldn't it be great if we actually produce? I mean, there is a mention in the beginning of this for larger installations about the technical manual. It's supposed to go into a pack with manufacturer's instructions and all the things. But something as simple as an illustration of the wall and the routing of the cables for the actual client to actually then understand how to safely work around the electrical installation you've provided seems like it's such an obvious thing to me.
Yeah, but we don't do it. You know, and this is why I say. I tend to say to guys now on inspection and testing courses, do it. And I say to them about putting a little pack together, all the information, manufacturer's instructions and the operating instructions for things like your bathroom fan timers, your PIRs and stuff like that. Put that all into a pack and give that to the customer along with all the inspection and testing sheets. Okay, it looks professional. You can put logos on everything. You can make it part of your marketing. And the customer will look at what you've given them.
Value.
And look at what somebody else has got from Joe Bloggs down the road, who knew a bloke down the pub who did their rewire for cash, you know, and they think, well, hang on, perhaps I didn't get such a good deal because this person who's paid for a proper electrician has got all this information, and I just got a system which seems to work, but I'm not really sure.
Yeah.
You know, it's good. It's good marketing. It's good professional approach to the work. So. It's something worth considering. Put a pack together, give it to the customer, give them that information. Okay, so as I talked about three-phase. You know, if we're doing three-phase insulation resistance testing, again, we've got nowhere to record the individual results. And commonly, when we're doing three-phase insulation resistance tests, we could end up doing up to 10 tests on that. So, again, as I said to you earlier this morning, really, we need to be looking at a separate type of form when we're looking at three-phase installations. This form does not work, and it does say, I know it says in the regs, says this is for domestic installations,
domestic up to 100,
small installations up to 100 amps, but nobody's ever said to anybody, well, what do we use for bigger installations?
And that technically does give you free license to create something, really.
Use it as a basis, but do your own, develop your own, and, you know, don't be worried about doing your own stuff, guys. Okay, so we got SELV or PELV circuits. We got SELV lighting, PELV lighting. Where on the form do we put that? Because we've got to make sure that we've got, if we're using SELV transformers, that we've got electrical separation, we've got to make sure that the SELV circuit is tested, as well as the LV circuit. So we've got several parts to, if we've got SELV lighting in a system, we've got the LV part of the system, we've got the actual SELV transformer itself to make sure we've got electrical separation, and then we've also got maybe the SELV part of the circuit. There's nowhere in the form for it.
No, because right now there's just a tick for compliance with the protective measures required in the inspection schedule. But as we know from the testing, there are requirements of different values of insulation resistance, different applied voltages, different conditions. So it's not a does that just come under the generic insulation test on the SELV circuit or not? And in the future, we are going to have a lot more systems of ELV. Maybe even going down the data route, and we're going to have to look at how that integrates. So segregation of these different systems is going to become a lot more of a requirement.
Well, when you consider, take one test on its own, the electrical separation test, which is 500 volt looking for 5 megohms. Okay, it's a totally different test to insulation resistance, but there's absolutely nowhere on the form for us to put that. So once again, perhaps we should be designing our own forms. And again, that's one of the things that I've got on mind. But if we do have SELV or PELV systems, we've got very limited opportunity to record any tests that we do on it. So once again, like the gentleman said earlier, people end up writing it on the back, which is great because it's recorded. But why should we be doing that? There should be a proper form for this.
Yeah, you've mentioned obviously the installation disconnecting equipment. There's a couple of comments there about USB sockets as well. Often these would need to be disconnected. These little new introductions to the work just suddenly change the performance of testing. You go from one job that has no USB, you carry the IR test the way you've always done it. You go to another job where 2 USB sockets have been introduced. They may not like the installation test.
They may not do. And this is, again, one of these situations where you have to install in preparation to test. So in those situations, if you've got USB sockets that don't like the insulation resistance test and are giving you false readings or whatever, you may have to just leave that socket down and actually just connect the cables together at the socket outlet, do the test, and then connect the socket outlet afterwards. Now, if you have to go down that process, and obviously you've got to absolutely make doubly sure, be very certain that when you're connecting up, you've got your polarity right and you've got your connections right and you do everything correctly. But with USB sockets, they're a real issue.
Also, USB are a source of their own supply technically, so we would have to in some way either plug in a USB tester to verify the output of the current and the voltage. There's nowhere to
so
where do we get
where do we get the test? Where do we get the tester from and the test leads? And where do we
actually
record the result?
You can buy USB testers. I think someone just mentioned Climate one. I think is it Martindale or Amprobe or someone else makes one, but I'm thinking of a couple in my mind. But reporting that information or functionality or confirmation
part
of
functional testing, isn't it? Surely.
Yeah. Well, again, but that guidance there. This is why 2391 needs to evolve.
Indeed,
a bit,
2391 is getting old. When we need to update it, we need to start including these new technologies, smart technologies, and everything else. You were talking yesterday about smart technology on the BS 7671 Future webinar with Paul. We need to start embracing those new smart technologies. Otherwise, we're going to fall behind. And we've got to look at it as a real opportunity, actually, for more work for electricians. Rather than thinking, oh, Christ, I don't know anything about that. I'm not sure if I can do that. We need to embrace it. And it's an opportunity.
We're just talking about 2391. Stevens just said they've simplified 2391 because not enough people were passing it. Now, you and I have delivered 2391 for a long time. Are we going to say that they've simplified it?
Yeah. I've got to be honest here. It's not what it was. The old 2391 years ago. Before the 2394 and 2395, the old 239 was an absolute bugger, and it was a proper test, and it was difficult. They then split it into the 2394 and the 2395, and they weren't too bad. You had the written exams. The written exams were the ones that used to trip people up.
But that's the key, though. That's the bit that actually gets engineering judgment.
Absolutely, and exams and assessments shouldn't be so easy that everybody passes. I'm a firm believer in any training establishment, anybody that says, oh, we get 100% pass rate, well, there's something wrong with your assessments, mate, because not everybody can pass. especially not everybody passing first time. The 2394, 2395, I think nationally they had a pass rate that wavered between 40% and 70%, depending on which edition of the exam you did. The exams used to go like, there was a hard one, then there was an easy one, then there was a hard one, then there was an easy one. And so if you timed it right, you got the easy exam. And City and Guilds, I don't know what's going on there, but it seemed to be that City and Guilds would, oh, hang on, we only got 40% of people passing. We'll make the next exam easier.
There are just a couple of questions that would go around the circle that would catch people out a lot of the time, and then they'd throw them back in and then they'd take them out.
Yeah,
that's the way it was structured.
But so the 2394 to 2395 in themselves weren't so bad. One of the issues, though, was that the 2394, especially, they started almost giving it away on the modern apprenticeships.
Well, they have, haven't they?
It became part of the modern apprenticeship. Yeah. But the assessment processes and whatever weren't as strict, shall we say.
Yeah.
You know, because you had a number of guys all going through their inspection and testing practical, right? And inevitably they ended up getting assistants and almost being spoon-fed. Some of them. I'm not saying all of them. I'm saying some of them, because I've seen it in action.
And it upsets me, though, because it means that guys who want to do the 2391 today, you know, they can only do the qualifications that are offered to them. And
yeah, absolutely, yeah.
And we don't want them to cut. You know, we don't want to keep referring to them as not having the old. And we need to find ways to enhance this level, to raise it up again, to actually give them that.
Yeah,
ability on it.
And this is where you and I have been working together on stuff, and you use this terminology quite a lot, leveling up. Yeah,
trying to.
So rather than just doing the basic 2391, we tried to deliver a little bit more than that, and we tried to get people up to a bit of a higher level, a bit more understanding, a bit more knowledge, and that's important. We don't just want to get people scraping through an inspection and testing, ticking the boxes, and saying, right, off you go.
No, because we're going to just have this form-filling nonsense.
Yeah.
Forevermore. We need people to apply it.
Yeah, but I've got to admit, you know, the simple answer to the gentleman's sort of statement is yes. I have to agree that the 2391 now is easier. You don't have the written exam that goes off to City and Guilds.
Yeah, no, Here's my problem with it. Obviously now, City and Guilds are saving a lot of money because they don't have to have markers write written exams. It's all on demand. The written assessment part of it now is pre-written, which means it's written once. I don't know if they update it every year or so, but the questions have been written.
No.
So I know the questions right now. And if I know the questions right now as a trainer that my candidates are going to have to sit, I can adjust my training to them. I can feed them that information to get them through. But before that, it wasn't. The exams would come in a grey envelope, just a day or so
in a plastic envelope,
exam, and
you weren't allowed to open it. 15 minutes.
Yeah, and City and Guilds would do random visits, and they'd come around and visit you, and if you'd opened the envelope, you were...
That was it, yeah.
So you had to keep them sealed. It was all well, and you didn't know what the questions were, but now you do. I'm not saying that this is in any way going to adjust the way trainers are delivering it, but I know that they're aware of it.
We know from experience there is that, you know, there's a tendency. People are sort of drawn to, oh, hang on, let's have a look at the questions, or we'll sort of direct our training to make sure we cover those points. And if you've got the same 6 questions all the time, or same 4 questions all the time, then nothing's going to change, is it?
Yeah. Let's get back onto this. But
okay.
Everyone watching, we are passionate about the subject. We're passionate about doing it properly. We agree.
Yeah, absolutely. And that's not to say that the guys, some of the guys that are going through training at the moment, some of the guys that have been through training recently, some of them are really good sparks. Yeah. I'm not saying that, you know, everybody is not as good as they used to be, because I'm not. There's a lot of really, really good guys in the industry now. Guys, you know, girls. There's a lot of really good sparks out there.
Yeah, I agree.
But the training it needs leveling up.
Yeah, it does.
Let's move on. Earth fault loop impedance. There's 2 methods that are prescribed. The measurement using a tester. Yay.
Yep.
Or calculation of R1, R2 plus ZE. There's arguments that have been made to support this business of doing the calculation method and not actually doing a proper
I'm gonna
measurement.
I'm going to throw something at you now, Father.
Go on.
I'm hearing a lot that the NICOC are saying you should just calculate ZSs on your light circuits because it's not live work and it's safe.
Yeah, I'm sorry. I don't agree. I just think that it's a test. If you're going to test ZE, how are you going to test ZE?
Oh, that's a live work. That's fine.
So it's okay to test ZE live, but you can't test at a lighting circuit.
Well, that's different. It's about minimizing the extent of live work, and they think that it's okay to calculate all the time.
Yeah, I personally don't agree, because I think actually doing the proper test, getting a proper value, has got great merits, rather than using a calculated value, which could be, maybe, possibly, depending on where you've taken it from and how you've taken it, could be affected by your testing regime. Yeah, you may have all sorts of things that are going on. I just think proper testing of a ZE and as a proper ZS is king. I always test. I don't do this business of add this to add that. I do it as a check. Yeah, as a check. The one time I will do it is if I've got a dead installation, brand new. Yeah, I haven't got a supply coming in yet. Okay, and then I can get my ZE by inquiry, which we all know is a load of nonsense anyway, because they'll give you a bog standard figure. All right, and I've got my R1RN, R1, R2, and I can do my calculations from there. I use my R1, R2 to give me my ZS, all right, and I'll put that on the forms. But those forms are then hung by the fuse board. The DNO will come in, see that I've actually tested the thing and I know what I'm doing. Then they'll give me a supply. Then I'll just simply take those forms and redo the whole lot, tear up the forms I had initially, just using the same test results, okay, and actually do the proper live testing rather than calculated values.
I think the argument is in domestic, it's most likely to be a PVC insulated and sheathed wiring system. So the presence of parallel paths are going to be non-existent. This is a lot of assumption. And therefore, this is the thing. If I was to say, you can't calculate them because you must consider parallel paths. And parallel paths obviously result in lower impedances. The R1 plus R2 does not include parallel paths. And so combining a parallel path with lower impedance, and lower impedances, we know, will increase fault current. And I think what they think of it is, well, because you don't have parallel paths in the dwelling environments, we can lean on calculation and keep people working safely. I don't like it. I don't like it. I think that's why they say it.
I know that testing light fittings, for instance, with pendants, ceiling roses, if we still use the things, that can be awkward. I know that. But things that I know Q-Tech and various other manufacturers do an adapter you can actually put into your lamp holder, and you can stick your test leads into those. Obviously, you sometimes get your polarity crossed over, but if you've checked your polarity on your continuity test already, then that's fine. You can just swap them over. And then the only thing you need to do is then make contact with the earth point on the ceiling rose. You're not actually going in with probes into the actual ceiling rose itself. Okay, so that actually makes it even safer. I just think that we're electricians. If we can't do earth loop impedance testing at the end of final circuits, then
who else can?
I might as well pack up. I might as well just go and.
I've just seen a comment, and I've had this discussion a few times before about it's live testing, not live working. I saw a couple of people have said, it's not live work. Now, the problem with this is, what is live work? Okay. Now, this is the Health and Safety Executives HSR 25 book, Electricity at Work Regulations. Yeah. Now, according to this, under Regulation 14, which is the live work regulation, paragraph 218, testing, it says Regulation 14 will often apply to electrical testing. Testing to establish whether electrical conductors are live or dead should always be done on the assumption that they may be live, and therefore it should be assumed this regulation is applicable until such time as the conductors have been proved dead. So, from the perspective of this, any work that is electrical testing, whether it's working live or working to prove dead, is considered to be under the requirements of guidance of Electricity at Work Regulation 14, which is live work. So it's there's a couple of things here. I mean, there's live work, there's live testing. If the system is energized and you're exposed to it, it's live work, isn't it?
Yeah.
If I've disconnected the system, and I'm doing continuity testing, that could be dead work. if I'm doing installation tests and I'm using a source of power from my battery instrument, which can generate up to 500 volts DC,
That's live work.
that's live work. So what is if it's not live work in this?
Okay. So are we saying that we can't do insulation resistance testing now because it's live work?
I'm not saying you can't do it. I'm saying you must comply with the requirements listed in Regulation 14, which is determining if you need to do it, you need to be near it while you're doing it, and what suitable precautions you are taking to prevent injury.
Absolutely.
If we say it's not live work, then we're not doing the requirements of electricity work regulations. We need to say, yes, it is, who should be near it, who should not be near it, and what precautions are taken to control it.
Yeah, and the same protocol applies all the way through testing. Is that we always have to be aware of who's around, who's actually anywhere near the installation when we're doing the test. Okay, and we have to control that and manage that. All part of the sort of method statement and the the risk assessment. But when we come to earth loop impedance testing, okay, we've got 230 volts on there. We're going to do a test on it, and it's always live work. We can't do that because it's live work. Well, we're doing insulation resistance testing, and that's live work.
Yeah.
So if we're going to say, well, we can't do earth loop impedance tests, we need to use measurement or calculation only because we can't do that, then we're going to have to turn around and say we can't do insulation resistance testing.
My opinion is this: electricians, if they're competent and they're trained and they're experienced, should carry out live work as part of their requirement to maintain systems.
That's why we're electricians.
The problem is other people that are not electricians, that are bodies that influence the way we work, start to mess this around and tell us what we are not doing or what we are doing. And they misinterpret what we're doing and they skew it, and they try to apply the best engineering judgment for us when really they're just fucking it up.
Yeah, basically. At the end of the day, anybody doing inspection and testing should be competent and electrically skilled to do that work.
I'm seeing people use the word common sense in chat. How dare you?
Oh, whatever. Go and wash your mouth out.
Yeah, how dare you? It's true.
Oh, dear. Bring it back, please. Yeah.
All right, Pop, look, we've hit the hour, so let's get the rest of this done.
Let's move on then. Okay, so looking at earth fault loop impedance, the other thing, come to three-phase. When we come to three-phase doing earth fault loop impedance, we tend to test all three phases. We've only got one box. So again, the documentation is not adequate. So we need to, again, look at, a lot of this relies on having the right documentation. And I really cannot impress on people enough. We've got to start doing our own because the proprietary documentation isn't up to scratch.
No.
Prospective fault current, this is the big one. Another big one for us anyway.
Yeah.
The regs require PFC to be determined at every relevant point in the circuit. Now, this is normally taught as, okay, you're going to test at the origin, and you're going to test at any dBs further downstream if your fault current is still too high, your short circuit current or your earth fault current, whichever is the highest. Because what we're worried about is you're going to blow your protected devices to pieces. Okay, so we check the fault current at the origin, we check it against the incoming protected device, we check it at the dBs, we check it against the protected devices in the dB. Have we got the right rating of fault current? Are they M3? Are they M6? Are they whatever? Okay, and that's how it's always taught, and that's how it's always delivered. Well, what about testing at the end of circuits? Okay, who tests prospective fault current at the end of circuits? And one of the issues we've got is when we look at overcurrent protected devices, we are more and more reliant nowadays on RCDs for, our RCD is this huge safety net that does everything. Whoopie-doo, it does all sorts. But they do not provide overcurrent protection. Yeah, they only provide earth fault protection. They will not protect against from short circuits from line to neutral or line to line, generally, and they won't protect from overload. So we need MCBs or part of the outside overcurrent protection. Most DBs use the type B MCB.
Your internet's dying.
Oh, is it? Okay, sorry. Yeah, it'll come back in a minute, honestly.
Yeah. Put key in the meter.
Yeah, put another shilling in. Okay, the regs require disconnection mostly for most final circuits within 0.4 seconds. Yep. Okay, to achieve this, we need a certain amount of current going through the protected device. Appendix 3 gives the details in the regs book, the time current curves, but generally we can say that a type B requires 5 times the nominal current, a type C 10 times, and a type D 20 times. So if we've got a 32 amp type C MCB, we'll need 320 amps of fault current to go through that for it to trip within the required time. Now the problem comes with when we got circuits which are a bit longer than maybe they should be, or maybe the cables haven't been adequately sized in respect of the length of the circuit. And we're lulled into a false sense of security by the RCDs because we do these earth fault loop impedance measurements. And even if the earth fault loop impedance is slightly exceeded, we'll accept it because we've got RCD protection. And the RCD will still work if we got 1,667 ohms, if we do. But so we're lulled into this false sense of security. Many circuits don't have sufficient fault current. We're talking about short circuit current, not earth fault.
Short circuit here.
Yeah, short circuit, because on under earth fault current, the RCD will operate. But under short circuit current, aligned to neutral fault, they don't have sufficient current to operate the device.
We had this example recently. We had C32 RCBOs on a 4mm radial circuit wide than FP. I think that's right, isn't it?
Yep.
It was going into a bar area, and we were just measuring the impedance, and it was going up and up. We went to the furthest point, and we had a prospective short circuit current. So we went onto the line to neutral test on the instrument, and we had 198 amps or 190 amps or something.
Something like that, yeah.
Yeah, and we know straight away we need 320 for instantaneous disconnection because it's a C32. So what we did is we just looked at that current level and we engineered the calculations to say, right, well, what would the disconnection time be with 190 amps? It would be, was it like 14 seconds or something? Or I can't remember.
Disconnection time would have occurred in 14 seconds on that.
But then we went to the fault current calculation. You know that T is equal to K squared S squared over I squared one?
The thermal withstand.
In chapter 43, section 434. We calculated the T is the time to calculate. The K, I think, was 143. Was that the factor? Because of the thermosetting insulation.
Yep.
Okay, K squared, S squared was the size, which was 4 squared, over the 190 amp squared. And we got 8 seconds or something. And that told us that, that current would take about 8 seconds for the insulation material to go way beyond its 90-degree limit temperature. I think the final temperature was like 250 degrees or something like that for the thermosetting. And it's not going to disconnect before that happens. No. So the short circuit occurrence on the equipment connected to that socket would damage insulation beyond repair and would potentially create a fire.
Yeah. So we've got a device which is going to disconnect in 14 seconds, but the cable is going to degrade and possibly catch fire within 8 or 9. So rather than an electric shock risk, we've got a fire risk.
Yeah. So,
and this is overlooked.
It is,
unfortunately, hugely overlooked when we come to fixed installations. And I must admit, I really came aware of this when I'm doing temporary stuff.
Yes,
we do it on temporary systems all the time. We test at the end of circuits.
We mentioned this in our 7909 webinar yesterday, and that's where we've kind of. It's taking that and then taking it into the 7671 territory and going, where is this in this? And we're like, well, it's not in there.
And it's not. And there's nowhere on the forms again. So and it's never taught. I say never taught. It's not normally taught.
Not normally taught.
We've been teaching it for a while now. We're always telling people now to test the short circuit current and into circuits. Say when you look at the sequence of testing in the on-site guide and in the guidance note 3, and when you work in FE colleges, some of the FE colleges that I've worked in, it's never taught. And I just think it's one of those things where, okay, so it's okay to have a fire? I don't think so. No. So when we're looking at protection of safety, we're looking at electric shock, we're looking at fire, we're looking at overcurrent.
It does say that. It says it in the fundamental principles that the circuit impedances shall be adequate. And that's what this is. It's a circuit impedance, not an earth fault. It's a circuit impedance. They shall be adequate. And that will help achieve the requirements of Chapter 42, which is protection against the thermal effects. So it's fundamental. I cannot believe it's not in there. I cannot believe it's not in there.
To me, it's a glaring omission from the inspection and testing sequence. Okay. Just the last few, which are more to do with the recording of them, phase sequence testing, we put a tick in. We put a tick. Fantastic. We've tested the phase sequence. If it's 1, 2, 3, why don't we put 1, 2, 3? If it's 3, 2, 1, why don't we put 3, 2, 1? Again, I just don't understand why we put ticks in.
There are some situations where the phase sequencing needs to stay the way it is due to the equipment or due to other people. That's fine, but you need to record its conditions so that people know when they work on it later on. You know, we've done that
Yeah.
before. We've worked on systems. We had one in Berkshire where they had an incorrect rotation.
Yeah.
And we're going, let's fix it. Oh, no, because the way equipment was configured and the way things were working, we couldn't change the rotation.
Yeah.
So anyone who works onto it needs to know that.
Yeah, as long as the phase sequence remains the same throughout the installation, that's fine. But why don't we put the sequence down rather than sticking a tick in? What does the tick mean? Oh yeah,
Check, really.
Yeah. Operation of RCDs. Yeah, we've got this thing now where we've just got the two boxes, haven't we? We've got the functional test and we've got one box now for recording the RCD.
I don't like the way they've done that. I mean, to me, the purpose of testing the RCD in this case, I think a couple of guys have just mentioned it. If the RCD has been installed for the purpose of additional protection, then I need to look at that times 5 because it's for the purpose of additional protection. If it's there for other purposes, such as 100 milliamp or 300 milliamp for requires like horticultural locations or other reasons, then the times 1. But that is the problem, having to determine the purpose of the RCD. And what if I've got an RCD for both intentions?
Yeah. And what if you look at the actual testing form from the on-site guide and guidance note 3, where do you actually put the rating of the RCD in?
Do you not?
You don't. No.
You don't put the type in, do you either?
No. So there's information. There's information missing.
It's just information.
Why don't we have that information? We put a test result there. Is that the times 5? Is that the times 1? Is it a 30 milliamp? Is it a 300 milliamp? Is it time delayed? Is it? We need more information. We need more space. Functional testing. We record the functional test for the RCD. We record the functional test of an AFDD. We don't record the functional test for MCBs or any other piece.
So in that case, the functional test is just the pressing the button in the eye's mind of this report. Yeah. What about all the other requirements of functionality of the circuit? Switches, breakers.
We are required, aren't we, to test MCBs now? We're required to do a functional test of the MCB. Make sure they operate, make sure they switch on, make sure they switch off. Why don't we record that? It's not on the inspection sheet. It's not on the test sheet. So, okay. Yeah, we're doing things. We need to record it. Let's record this, so we know it's part of the thing. So to summarise, I know we're over time again. Seems to be the bane of our life around there.
I assume so, really. We should stop this.
So number of tests that should be carried out to prove that the installation has been completed safely, and these are just simply missing. There's a number of tests that should be carried out to see that the installation will operate safely and continue to operate safely, and these are simply missing. And the inspection and testing documentation just needs a complete overhaul. Or, as I do, design your own, guys, and have the confidence to do that. You're allowed to do that, long as you've got the basics as shown in the on-site guide, as shown in guidance note 3 or in appendix 6 of the regs. Use that as the basis, but honestly, they can be improved tremendously, and you basically stick in there whatever you want to put on your forms. And if you need another 2 or 3 sheets, have another 2 or 3 sheets. Why not? Record all the tests that you do, record everything. When you come back to do an EICR in 5 or 10 years' time, you'll be looking at those thinking, then you can take an engineering view as to whether or not the installation is still okay, or is it degrading? And if it is degrading, how fast is it degrading? That's important information.
Nigel's just mentioned, ramp tests as well. All instruments these days are coming with that ramp test function. If I have a ramp test, I put that down. I can then come back 5 years later and I can do it again. And I can now see any decline in performance.
Showing exactly where the RCD is testing at.
If we could report the information when we come back in a few years' time, we have more information to refer to then to make decisions against. We can't make decisions against nothing. So, no, excellent. There's been such great conversations going on in the chat. It's really, really good. It's good to know that, people are kind of thinking about this themselves. Are we done, Pop?
I'm done. I'm done.
All right.
Cup of tea is calling.
Cup of tea, cup of coffee time. All right, guys.
I need a biscuit.
But listen, we are going to do another one this afternoon on Maximum Demand at 2:00. But we have got one more on EICRs tomorrow, and there's an Amendment 1 I'm going to do. But we're going to come back to EICRs tomorrow, where we're going to talk about codes, observations, inspection. So not so much about little tests, but more about the inspection side, the codes and things like that. That's the afternoon one at 2 p.m. I think, isn't it?
That's going to be a discussion as well, more than isn't it? It's going to be
more
like
discussion. It's so much more interesting to get discussion, and there's such great discussion going on in the chat, which is really good. So if you want to come check that out, double check the website to see the time. I think it's 2 p.m. tomorrow. I'm pretty sure. But hey, thank everyone for coming. If you have any more questions that we've not managed to answer in this, you know how to contact us. Any other points, Bob, to make?
Just thank you for listening to the ramblings of an old man.
There you know.
Thanks for taking part, guys.
Cheers, guys. Bye.
Cheers.
Cheers.